All right, calculus, here we are for your section 2.8 notes video day 2. This is for Tuesday the 26th. I've also sent you this following. This must have been like in the 7th edition book right here. I sent you this document, so I'm going to come over here later on and look at that and help you answer that. All right, so we've got some sponsors today. And, all right, so Cliff Bar, obviously, prime sponsor here. Let's get Rocky Mountain National Park in there as well. Lovely place. And one of Dr. Seuss's famous, there's a Wocket in my pocket. Excellent. Folks, do you ever feel like sometimes there's a wasket in your basket? Yeah, me too. So, got some noise here at the homestead today. My wife does work from home and she has a meeting upstairs and the door's not closed. You might hear her. We've got someone putting something together for us in the garage right now that might make some noise. And because Yogi can't let any noise be heard outside without it letting us know, he is currently residing in another room, so you might hear him wanting to be let out. Everything is fine. We will power through. Notes that f prime of x, the derivative of x, is the same thing as saying y prime. If you say like, well, first off, if y equals f of x, then y prime is equal to f prime of x. We'll talk more about that later, especially when we do implicit differentiation. It's one of the last things we do before the end of the semester, which is also dy over dx, okay, which is also df over dx, which is also d over dx of f of x. I can't explain what that means, but that's basically meaning d over dx, that just means that's the variable that you're differentiating, all right? You're differentiating with respect to x. All right, so we'll talk more about that, but that's when you see like dx, you're saying you're taking the derivative of x. That's the variable that you are taking the derivative of. All right. If f of x is equal to f prime of x, if f of x is equal to the square root of x, find f prime of x. We are using the limit definition. I sent you yesterday the rest of the documents for chapter 2. All right. You've got everything. You've got the quiz review, and then you've got the exam review. And at the end of the exam review, such a great exam review there. So many questions you can practice. It gives you the formulas you're going to have to know. And this is one of them. The limit definition of a derivative. The limit definition of a derivative. All right. So for us, f prime of x is equal to the limit of, I'm going to plug x plus h in for x, minus f of x all over h. It looks innocent enough. How do I get rid of these roots? Probably going to need to do that. I multiply top and bottom by the conjugates. And when I do that, I just do the first and last part of FOIL. X plus h falls on out, minus x. Oh, look at there. All right, cool. The x's will cancel, leaving you with this. All right, again, we've seen this different quotient before. We know how this goes. We know that the h's the thing causing the issue, so the h's cancel. Click is down. Put the rest there before you're eating. Then h, I can plug a 0 in for h. I made a mistake. I don't need to write the limit as h goes to 0 anymore because I've plugged a 0 in for h. And I get 1 over 2 root x. Some of you, after we do enough of these, because I'm going to keep them pretty simple, it's not fair to give you the real tough ones, but you'll be able to tell. Like you might get to the exam and you're like, I know what this derivative is going to be. I know it's going to be 6x minus 7, but you still have to show. This is a classic question. There is one always on the SIU final using the limit definition. There'll be one on your final, both in the fall and the spring, but there's a way to kind of check your answer. With the square root ones, you've got to be taught what the power rule of derivatives is. You won't be able to know that one right away. Anyway, that's a good one. All right, this is all about, you're going to have, I think, five of these on your homework set, number 4. which we need to start early. All right, I received so I'm making this video on Monday for Tuesday. Some of us kind of pushing it with that homework, turning in a little bit either late or little too close to the deadline, folks. Let's practice that homework early and often. All right. The goal is not to dominate high school. The goal is to handle the rigors next year. We can do that. Let's work on that homework early. Let's practice it, rough draft it, and then turn it in. You always want to have it totally done the day before it's due, so you can look over it one more time and send it in. That was always my goal. The day before it's due, it's totally done and looking good. All right. I do the same thing here. Find f prime of x, a few easier ones. So I need to do f of x plus h minus f of x. Make sure you use parentheses or a bracket when you're subtracting f of x. If you don't, the 7s won't cancel. Okay. So here we go. I do a little distribution. Negative 7 plus 7 cancels. I canceled them out. All right. The x's should cancel too. We know from the difference quotient that the only terms left right before I cancel the h's have to have an h involved. So the x's and the constants need to cancel. Then I divide everything by h. For x plus 2h in the difference quotient, I was left there, and I said, well, what happens if h was 0? You get a derivative of 4x. So now we're actually calculating derivatives using the limit definition. Okay, so we get 4x. This is about the easiest one I can give you right now. If f of x is equal to 3x minus 8, find f prime of x. We don't do a ton of derivatives using the limit definition because there's a much simpler way to find derivatives. All right, but it's important to know, again, it's all about that instantaneous rate of change. We want to home in on that value of x. If I want to find the derivative when x is 2, the rate of change would be 8. Then I want to really make that horizontal distance between the x's essentially nothing. I want to be right there. I want to be so infinitesimally close that I can say that the tangent, that the curve basically looks like a straight line. All right, so that is why the derivative has a limit definition. All right, we're saying that the horizontal distance between the x's is 0. I'm right there. Okay. And you got a little bit of a taste of that when we approximated the slope of a line somewhere. Okay. Remember we got we said 1.9, 1.99, 1.999. We're basically getting there. Anyway, long story short, this is f of x plus h minus f of x. Again, you're subtracting negative 8. Negative 8, positive 8 cancel. 3x, negative 3x cancel. You're left with 3h over h. What's the limit of 3 as h goes to 0? The limit of any constant as x or h or anything goes to 0 is just that constant, 3. All right, so those are 3 derivatives for us. Now, I've got some notes for me. Let's look at page 153. That is to me. All right, I'm going to move the daughter's stuffed animals here. Don't tell her. All right, look at page 153. What does page 153 have for us? Right here. A lot of times I print this, so here's what's going on. I'm going to be quick. So this is f of x. Okay, this is the original function, f of x. And when the slope is 0, i.e. when it's a local min or max, when it changes from decreasing, increasing, or increasing, decreasing, when the slope is 0, that means the derivative is 0. Okay, remember the derivative is the slope. So here I know derivative is 0, derivative is 0, derivative is 0. And that's going to be very important for us in chapter 3 and 4. Most of chapter 3. All right, so what they've done here is they've drawn a graph of the derivative. So, folks, this is the derivative. The tangent lines to the curve is going to be negative. So the derivative is negative from negative infinity to 1/2. So this is showing because it's below x. This is showing that the derivative is negative. Then the derivative is 0 at a, we'll call it, looks like a third. And then the derivative is positive from there to, maybe x is 1 and a 0.5. The derivative is positive. Then the derivative is negative from here to here. Then the derivative is 0 again. Then it's positive because it's increasing all the way to x is 5 and above. All right, so there you go. If a function is decreasing, the derivative is negative. If the function is increasing, the derivative is positive. And if the derivative is 0, the slope of the tangent line is 0, or if you've reached a minimum or a maximum, then the derivative is 0. So that's really important. The derivative is 0 when you have a min or a max. A lot of times in business and applications, we want to maximize or minimize something. So it sounds like when a derivative is 0, that's pretty important. So it's going to be a lot of what we do. When in doubt this year, take a derivative and set it equal to 0. All right, so now we're going to look at, again, I've written this out for you, other notations. Our man Leibniz, okay, he doesn't get enough credit, but he's the co-creator of calculus. I believe if you go into engineering and take differential equations, you'll see more of his influence than Newton. All right, so here's why 156. There's 3 different ways a function doesn't have a derivative. So where is this function differentiable? All right, so with an absolute value function that it makes a certain graph, right? Makes the v. So they do this work. So they're saying if x is greater than 0, you get 1, okay? And if x is less than 0, you get negative 1. All right? So, again, they're doing left and right side limits there. So when you have this sort of graph, and then we'll talk about jump discontinuities too. They talk about that as well. All right. When you have an absolute value function, where does it say that? If you have an absolute value function, which gives you a sharp corner, an absolute value function gives you a sharp corner, you don't have a derivative. If you have a discontinuity, you don't have a derivative. And in the weird case where you have some vertical tangent, you also do not have you don't have a derivative. Hopefully I said that, not discontinuity. Yeah, so if you have a vertical tangent, if you have a corner, and that's just kind of looking graphically. Now, if I give you, find the derivative of the absolute value of x, you got to know that's depending on if x is positive or negative, you get different value, either 1 or negative 1, using the limit definition. So sharp corner, a discontinuity, or a vertical tangent, there is no derivative. Okay, great. Now, before we go on to just 2 more derivatives, what I want you to do, and actually I think we have the same page. Well, maybe not. What I want you to do is go to this page I printed for you. All right, let's look at it. So we're just going to talk whether or not on this first one here. So what is the derivative at when x is a negative 3? So 1, 2, 3. It's still slightly going downhill. So the derivative is negative. When x is a negative 2, 1, 2, it looks like it's exactly 0. So for part B, we would say the derivative is 0. Then f of negative 1 at negative 1, at x is it's going uphill, so the derivative is positive. When x is 0, it's still increasing, so the derivative is positive. When x is 1, it's still increasing, so the derivative is positive. When x is 2, it looks like it hits a max, so the derivative is 0. And when x is 3, it's going downhill slightly, so the derivative is negative. So all we were doing is putting pluses or negatives. Pluses or minus there. Now, I do want to do all of 3. So this is a really good one. So match the graph of f of x with the graph of its derivative. All right, what did we just say when you're not allowed to have a derivative? When you have a sharp corner. So B has 2 sharp corners. So at like -3, it's got a sharp corner, so that means it's not going to have a derivative. All right, the derivative is it's gonna go from increasing to decreasing. So positive derivative to negative derivative, but right there's going to be some sort of hole. Look at that. Positive derivative, it jumps to negative, and then there's a hole. So graph B would match with graph 4. Okay, so then the derivative is negative, and then there's a sharp corner, which means you got a hole, then it jumps to being positive. So B matches with 4. All right, so then let's take a look here. Let's look at A. You have a negative derivative, and then like when x is -2, the derivative becomes positive. Then you have a positive derivative, and then when x is +2, the derivative becomes negative because it goes from decreasing, negative derivative, to increasing, positive derivative. So what happens there? So when x is like -2, it becomes positive. When x is a +2, it becomes negative. In between x is -2 and +2, you have a positive derivative, which you have here. So graph A goes with graph 2. A2, B4. Take a look here. C is pretty interesting. Again, we're talking about the derivative. So on C, you've got a negative derivative from like x is -infinity to 0. Then you have a positive derivative from x is 0 to infinity. C, and at 0 it changes. At 0 it changes. So C must go with 1. All right. And process elimination tells me that D has to go with 3, but here's why. You've got a negative derivative, and then like when x is -2, I'm sorry, the positive derivative. It's increasing means positive derivative, so that is my fault. You have a positive derivative, then an x equals like -2, got a negative derivative. All the way to 0, then it becomes positive again from like 0 to 2, and then you have a negative derivative. Again, positive derivative means that the curve is above the x-axis, positive derivative. It doesn't matter if it's also like decreasing. We'll talk about, what that means later. So D goes with 3. All right, this might not be the easiest, but there you go. All right, so that, I believe that is good for that discussion right there. Let's end it with finding 2 derivatives right here. This would be good for your, this is good for a certain homework set. Find f prime of x if f of x is, x minus root 3x. This one, I hope we pay great attention to. Hint, hint, wink, wink. Again, you'll be able to do this derivative in like 15 seconds in less than a month. So let's practice, using that limit definition. F prime of x is f of x plus h. Plug x plus h in for x. There and there. That is right here. F of x plus h in black. Minus, in blue, f of x. All over h. So the x's are going to cancel. That's nice. The x's are going to cancel. Here's what I did. I put the h first. Now, we've not really had I know I'm going to have a conjugate, but the conjugate's going to be root 3x plus root 3x plus 3h. It's not going to involve this h. So here's what I can do, folks. I can break this apart. I can say the limit of, because this is a fraction, I can write this fraction as h over h plus this over h. You know that from fractions and breaking them apart, especially in chapter 8 last 2 years ago in college algebra. I know you got those notes down when we were in quarantine. So I'm breaking this up in 2 different limits. I can say the limit as h goes to 0 of h over h plus the limit as h goes to 0 of this over this. Well, the limit of h as h goes to 0 of h over h is just, I should have actually written this, is the limit as h goes to 0 of 1, which is 1. All right, so it's going to be 1 plus whatever's happening here. Now, this shouldn't be too difficult. Now I'm going to multiply the conjugate of this, root 3x plus root 3x plus 3h. 3x minus this entire quantity, inside the root. Be careful. The 3x's are going to cancel. Yay, leaving you with this. Then the h's are going to cancel. Yay. Which gives you this. Now I can let h go to 0. And if I have 2 of the root 3x's, that is 2 root 3x. All right. Wow. A lot of work there. That is a really good one. Please look at that. Pause it. Watch it again. Again, you might not understand a question right away. You're going to need to watch some of these over and over. All right, cool. There we go. And lastly, let's talk about this one. These are great for your homework. All right, really good. So if f of x is equal to 2 over 5x, what's f prime of x? So it's going to be f of x plus h plus plug x plus h in for x minus f of x. All right, so really the only way to handle this is I, in the true numerator, need to subtract these fractions. So both of these denominators need to be the same. So they both have 5s. Oh, I can't simply just put a plus h there. All right. I need to give this x over x, and I give this x plus h over x plus h, which is what I've done. And now here's what's going to happen. It's going to be a minus 2x all right, so you're going to subtract the 2x, and you're also subtracting the 2h. So the 2x's are going to cancel, leaving you with a negative 2h over this common denominator, which is great because these, it's really h over 1. So this is the numerator of the numerator, and this is the numerator of the denominator. Anyway, I might not be precise, but you know what I'm saying there. Sometimes layman's speak there is more helpful. The h cancels, and that's great because it's going to 0. It's causing issues. Now I can truly let h be 0. I get negative 2 over 5x squared. All right, folks, please get on that homework so then you can spend all that time reviewing for the quiz, all right, because I have some questions. I'm going to subtract and then add on that quiz review, all right? So, on that quiz, that is, and the exam. So here it is, folks. This is Yak Math Videos, and we are signing out.